Hello students, welcome to the last session of the unit 1 Introduction to Hydraulic. This unit comes under the course Fluid Power Automation. In this session I am going to give a brief lecturing on fluid pressure, pressure head, gauge pressure, atmospheric pressure, absolute pressure and simple and differential manometer. After completion of this session, students are able to understand the concept of hydraulics, hydraulic fluids and its property. After the completion of this contents in this session, the students are able to learn the concept of hydraulic fluid and its property. Let's we move to the first content, fluid pressure. Fluid pressure is the pressure at a point within a fluid rising due to the weight of the fluid. It is nothing but the pressure is created at a point within a fluid. It is due to the weight of the fluid. This sketch is showing the different parameters. That parameters are used to find out in the fluid pressure. This is the formula is used to find out in the fluid pressure. The fluid pressure, it is equal to P plus rho GH, where P is nothing but pressure at the reference point of the fluid. The P fluid is the pressure at the point in a fluid. Rho is the density of the fluid and G is called acceleration due to gravity and H is the height from the reference point. This is the formula which is used to find out in the fluid pressure. In this unit, there are two factors that affect the fluid pressure. First one is depth of the fluid and density of the fluid. As the depth is increases, the pressure exerted by the fluid become more. Then denser fluid such as water exert more pressure than the lighter fluid such as air, because the molecules in the denser fluids are close to each other, that resulting in more collisions in the given area. Due to that denser fluids will exert more pressure than the lighter fluids. This result in exertions of the more pressure. In the fluid pressure is considered in two conditions. The first condition, it is in an open condition or it is in a closed condition. There are three methods that can be used for calculating of fluid pressure. The first one is it is depending on the density and height of the fluid and independent of the mass of the fluid. These are the point must be considered while measuring the fluid pressure. Let's move to the next topic is a pressure head. A liquid is subjected to pressure due to its own weight. This pressure is increases as the depth of the liquid is increases. So this figure is showing how to measure the pressure head. Understood? Here we consider a vessel containing a liquid as shown in the figure. The liquid will be exert pressure on all sides and bottom of the vessel. Now let cylinder be made to stand in the liquid as shown in figure, and here we have to observe there in the figure H is equal to height of the liquid in the cylinder, A is equal to area of the cylinder base, W is equal to specific weight of the liquid and P is equal to intensity of the pressure. Here how to measure the pressure head is now total pressure on the base of the cylinder, that is equal to weight of the liquid in the cylinder. Pressure on the base of the cylinder is nothing but P into A. P is a pressure and A is equal to area of the cylinder at the bottom. That is equal to WAH. W is nothing but weight of the fluid with the area of the cylinder and the height of the cylinder. Here we cancelling the common factors. Finally we will get the formula P is equal to WH. The P is equal to nothing but the pressure head, that is equal to W is equal to weight of the fluid, it is equal to height of the liquid in a cylinder. Here the P is nothing but it is the intensity of pressure in a liquid. According to that one, the depth will vary, the intensity of the pressure will also vary. That is the concept we are using to find out the pressure head. Let's we move to the topic the gauge pressure. The next topic is a gauge pressure. The gauge pressure is nothing but the amount by which pressure measured in a fluid exceed that of the atmospheric. It is measured with the help of the pressure measuring instrument. During the measuring of this gauge pressure, the atmospheric pressure is taken as a datum at the atmospheric pressure on the scale is marked as a 0. Means is nothing but when we are measuring the gauge pressure, the atmospheric pressure on the scale is marked as a 0. Gauge pressure is the pressure relative to the atmospheric pressure. Gauge pressure is positive for the pressure above the atmospheric pressure and it is considered negative for the below the atmospheric pressure. It means the atmospheric pressure is considered as a datum plane and datum reference, and above that varying of the pressure, that is considered as a gauge pressure, is a positive. If it is comes to below that atmospheric pressure, then it is considered as a negative of the gauge pressure. Let's we move to the atmospheric pressure. Atmospheric pressure is nothing but the atmospheric air is exert normal pressure upon all surfaces with which it is in contact, and it is known as a atmospheric pressure. The next topic is a absolute pressure. The absolute pressure is nothing but it is sum of gauge pressure and atmospheric pressure. Here the formula we are using to find out the absolute pressure, P abs, that is equal to Pg plus P atmosphere, where P atmospheric is the absolute pressure, Pg is equal to gauge pressure, the P atmosphere is a atmospheric. It is nothing but sum of the gauge pressure and atmospheric pressure we are considered as a absolute pressure. In this sketch we can able to easily understand how the absolute pressure will be measuring. The atmospheric pressure is considered as a datum line. In a last slide we discussed about the gauge pressure. In this sketch you can able to understand easily. See, this atmospheric pressure is considered as a datum. Above that datum plane we consider as a positive gauge pressure, and below that one we are considered as a negative gauge pressure. So it means when we are measuring the gauge pressure, the points which comes above that datum plane, that is considered as a positive gauge pressure. If it comes below that datum plane, we consider as a negative gauge pressure. In the measuring of absolute pressure, we are adding gauge pressure, which may be a negative or positive value, and along with that one atmospheric pressure. If we are addition of these two values, then we will get the absolute pressure. Next we move to the topic is manometer. Manometer is the device which is used to measuring the pressure at a point in a fluid by balancing the column of the fluid by the same or by using of the different columns. The manometer are classified as follows. The first one is a simple manometer, second one is a differential manometer. In the simple manometer, there is a different types. It's a piezometer, U-tube manometer, single column manometer, and differential manometer is having the U-tube manometers with a different columns. The simple manometer is a device, is one which consists of a glass tube whose one end is connected to point where pressure is to be measured and other end is remaining open to the atmosphere, and pressure is applied onto the fluid. There is an head we will be get, it is indicated by letter H. Okay, by using of that one, how much of pressure is in the line we can able to easily measure. This is the sketch is easily show and how simple manometer is works and how we will be measuring the pressure. And this is the formula we are using to find out in the pressure in the piezometer, and the P is equal to rho GH. The rho is nothing but the density of the liquid, H is nothing but height of the liquid in piezometer from the center of the pipe, and G is the acceleration due to gravity. It is nothing but G is equal to 9.8 per Newton per meter square. And the next one is an U-tube differential manometer, where we are used as a simple manometer piezometer. Here we are using the two differential head in the U-tube manometer, and the principle of manometer is that the pressure is to be measured is applied at one side of the tube, producing the movement of the liquid as shown in the figure. It can be seen that the level of the filling liquid in the leg where the pressure is applied. Therefore, the left leg of the tube has dropped, while that in the right leg it is risen. Means it is a rise. A scale is fitted between this tube to enable to us to measuring the displacement. Let us assume that the pressure we are measuring and have applied to the left hand side of the manometer is of constant value. The liquid will only stop moving when the pressure is exerted by the column of the liquid. H is sufficient to balance the pressure applied to the left side of the manometer. Therefore, when the head pressure produced by the column H is equal to the pressure measured. This is the concept and principle we are using to find out in the pressure in the U-tube manometer. This figure shows differential manometer whose two ends are connected with it different points A and B, the same level and containing the same liquid. See here. H is nothing but in the figure showing the difference of the mercury level in the U-tube. And H1 is the distance of the center from the mercury level in the right limits. And S1 is a specific gravity of the liquid at the 2 points A and B. S is a specific gravity of heavy liquid or means the mercury in the U-tube. HA pressure head, HB is a pressure head at B and A respectively. This is the formula which is used to find out in the pressure at the manometer. HA minus HB is equal to H into S minus S1, which is a formula which is used to calculating the pressure at the point. Up to this we are discussed many topics which comes under in hydraulics. This is the basic concept of hydraulics and properties of fluids. Next we move to the multiple choice questions which are related to this session. The first one is force per unit area is called. It's a simple one. We already discussed this in the last sessions. It is called pressure. Second question is the pressure of liquid on a surface will always act dash to the surface. There is a 4 option: parallel, second one is a normal, third one is a 45 degree, and last one is a 60 degree. We know that The pressure of the liquid on the surface will always act normal to the surfaces. And the next question is the height of the free surface above any point is known as. This point we discussed in measuring of gear pressure. When we are measuring the gear pressure, we are using this is a datum line. It means the answer, there are four answer: atmospheric pressure, gear pressure, either of above the and none of the above. It is nothing but it is either of the above. It is an atmospheric pressure and gear pressure. And the last one is manometers are suitable for comparatively dash pressure. First answer is a low, second one is a high, third one is a very high, and last one is a none of the above. The manometers are suitable for comparatively the low pressure. Thank you to all those who are listened the lecturing and participated to this session. Thank you.